Welcome back again, Visual Basic in the Express 2012 edition. This particular episode is to show a few things, mainly, again, very bad practice. We're going to use some Visual Basic PowerPacks, which are built in down here, and we're going to use the oval shape. Visual Basic 6 had controls for shapes, but they basically went away when visualbasic.net was brought in, and now they've come back in the form of these PowerPacks. They can be quite useful for doing diagrammatic representations of things, so it's well worth being aware of how you can use them. But I'm going to have a look also at some more debugging and what's called refactoring, changing your code to make it work properly when it's got mistakes in it. So I've designed a form here. Again, very simple form, one button on it. When we run it and click on the Run Me button, it asks us for an X coordinate, and I'm going to put in 100, and a Y coordinate, 100, and it's going to put an oval on at the coordinates I've asked for. Wait, that's not at the coordinates I asked for. That isn't at 100. That's on the left-hand side. So, what's going on? Let's stop the code and go and look at what I've actually written. First of all, just so that you know how to use the shapes that are in the PowerPack, you have to add a shape container. So that's declared up here, dim shape container as a new PowerPacks.shape container, and when I load the form, I add it to the controls collection so that it will show on the page, which is similar to what I did before with buttons. I can then add things to the shape container and they will show up on the form. So the button I've got is handled by this particular subroutine. It creates an oval, dim oval, as new PowerPacks oval shape. We call a function to get the location that we want to put it at. And I've used this, I mentioned it before, fields of the form essentially as though they were global variables. And I mentioned before that can be bad practice. If you look closely at this code, you may well be able to spot what's wrong with it. I've not made it a particularly hard piece of code to debug because I don't like having to debug hard code in videos. So after getting the location, we set the location to a new point, and that represents somewhere on a two-dimensional plane based on those values here, which getLocation will return for us. We set the size and we add it to the form, or to the shape container on the form. So what does getLocation do? It dimensions two local variables which it inputs into, or gets input from the user, and it checks to see whether or not those are too far to the left or too far up the screen. If you're doing this properly and you wanted those checks to be working, you'd have to check for the right and bottom of the screen as well, but we won't worry about that. And then it returns a new point based on those local variables. So that looks like it should be working, really, doesn't it? Okay. A few things which are clearly wrong when you look at the code more closely. Here, I've actually used lock_y, which is the form level variable, which is in scope for everything that's here, whereas here I've loaded from the user the input into the local version, local lockx. So I check local lockx and I check lock_y, so because those are the ones I put in, and I return the new point based on the local values. The problem is I never actually put anything in to the lock_y value. So it's not working the way that we expected. So you start, whenever you see something like this, if you see the line lengths don't match and you're doing very similar things in the two of them, text strings can obviously make a difference to this, but it's worth being aware that something might be wrong when things don't match up. Good code often looks quite pretty and lined up with itself. So let's, as a first step, we'll go in and we'll see how it actually behaves. We'll put a break statement in here on that line, which we can, as I say, we can either click there or we can press F9 to toggle it on and off. And I'll start the code, bring that back down here, run me, and it'll pause at this point. So we'll step into this, or step over it technically, and I'll put my value of 100 in as an x coordinate, and we now see that loc x is 100. Do the same for the loc y, 100, and loc y is 100. So now what happens? Well, loc x isn't less than 100, so it skips over, and loc y isn't less than 25, so it skips over, and it returns a new point based on 100, 0, because we haven't actually set loc y to have a value, and Visual Basic automatically assigns things like integers a default value. In this case, that's tripping us up a bit because we may not have realized that we hadn't assigned anything to it. So I'm going to stop the code there because we know that we can fix that bit. Let's change this to be loc y, and in here we know that that wants to be loc y, and here, because what effectively we were doing there was programming by side effects. We were sort of hoping that we were going to have changed the values here by what we did in the function down here. So I'll run it again. Run me breaks at that point. Step over, put in the value of 100, and step over and put in a value of 100. So again, it's going to step over these because neither of those conditions are met. It returns a new point with 100, 100 in it. And when we come out of the function, location is now equal to getLocation, and we then carry on. I'll just run it. What happens? Oh, of course, now it's up in the top left-hand corner. That's at 0, 0. Top left-hand corner of the shape is where the coordinates point to. Stop that again. What did we do wrong now? Of course, here we've set the new point to be based on those values. And actually we didn't want to be doing that at all. What we want to do is set this to be the value that is in location. Okay, so that's a little bit better. Let's run it again. Run me. It's going to stop there. Actually, I can turn that off. Carry on running with F5. Let's give it some different coordinates. We're going to make it 120 across so we can tell the difference between the x and y coordinates, and 50. 120 across and 50 down. So that's looking okay. If we run it again, now this time we're going to give it a small x coordinate, so we'll stick it at 0, bearing in mind that we've got this code here to trap that condition, and we'll still make the other one quite a large number, so we'll make that 100. So now that's working. It's got an indent of 40 and it's 120 down. So if I stop that now, you'll see that we're actually no longer using these two variables at all, so I can get rid of them. And it is generally best, as I say, to work with variables that operate within the scope rather than with global variables, because they can cause you problems. It's also worth having a quick look while we're here at the point, so it won't work there, at the point data type. And so we'll run it, we'll click on the run me, and we'll go for 93 and 22. And you'll see it stopped here. Now we can look at the value of location. You'll see on the screen at the moment it's got a little pop-up which tells us, but let's look at it in the watch screen down here. It's a point which has an x value of 93, a y value of 25 because of this code which trapped it, and you can see that you can also access each of the individual bits as x and y. Being able to follow this code through makes a huge difference. The variables through makes a huge difference when you're trying to debug something and work out what is wrong. And I thoroughly recommend actually writing code with mistakes in occasionally, so that you can get used to using the debugger to step through. So that's a very simple look at some of the problems you might get into, particularly if you mix and match the idea of class level variables and local variables within functions, and how you can use the debugging very simply. Okay, so have a play with those ideas, and make sure that you also explore things like PowerPacks. So where you have a toolbox, we've got all sorts of things here, menus, we've got data. Make sure you have a look at those and work out how they behave.